Have you ever looked up at the night sky and wondered, just how big is the universe? It's a question that has fascinated humans for centuries, and for good reason. The universe is mind-bogglingly huge, filled with billions of galaxies, each containing billions of stars. When we talk about the size of the universe, we often talk about the observable universe. This is the part of the universe that we can see from Earth right now. Imagine shining a flashlight into a dark forest. You can only see as far as the light reaches. The observable universe is like the area illuminated by our flashlight. It's a sphere with Earth at the center, and it has a diameter of about 93 billion light-years. To put that in perspective, 1 light-year is the distance light travels in a year, which is about 5.88 trillion miles. But here's the thing. The universe is probably much bigger than what we can currently observe. Just like there might be more forest beyond the reach of your flashlight, there's likely much more universe beyond what we can see. Imagine you are standing on a vast, flat plain, and you can see all the way to the horizon in every direction. That horizon is like the edge of the observable universe. It's not that the universe ends there, but rather that the light from beyond that point hasn't had enough time to reach us yet. The universe is about 13.8 billion years old. That means that the farthest we can see is about 13.8 billion light-years away. But the universe has been expanding this whole time, stretching space itself. Because of this expansion, the actual distance to the edge of the observable universe is much greater than 13.8 billion light-years. Scientists estimate it to be around 46.5 billion light-years in every direction from Earth. That makes the diameter of the observable universe a whopping 93 billion light-years. It's hard to wrap our minds around just how vast the observable universe is, but it gets even more mind-blowing. Remember, the observable universe is just the part we can see right now. There's no reason to think the universe just stops beyond that point. Imagine you've reached the horizon you saw on the vast plain. As you walk towards it, a new horizon would keep appearing in the distance. The universe might work similarly. What lies beyond the cosmic horizon we can currently see, we don't know for sure. Some scientists believe the universe might be infinite, stretching on forever in all directions. Others think it could be finite but unbounded, like the surface of a sphere. On a sphere, you can keep traveling in any direction without ever reaching an edge. The truth is, we don't yet have the tools or the knowledge to definitively answer the question of what lies beyond the observable universe. It remains one of the biggest mysteries in cosmology. So how do scientists even begin to measure the distances to stars and galaxies billions of light-years away? It's not like we can just grab a cosmic tape measure. Astronomers use a variety of clever techniques to measure cosmic distances. One important method relies on the properties of light. Light travels at a constant speed, but it can get stretched or compressed, depending on whether the object emitting it is moving towards us or away from us. This is similar to how the sound of a siren changes as an ambulance approaches and then passes by. By analyzing the light from distant galaxies, astronomers can determine whether they are moving towards us or away from us, and how fast. This information, combined with other observations, allows them to calculate the distances to these galaxies. It's like using a cosmic radar gun to measure the universe's expansion. Thinking about the sheer size of the universe and the mysteries that lie beyond our current understanding is a humbling experience. It reminds us of just how much there is still left to discover and explore in the vast cosmos.